Hello everyone. Today I want to go over security lab number 4. Um, go over the steps and show how everything works. So lab number 4 is about the software defined network implementation of access lists. So you have did or you have studied access lists in the lecture, and you did a lab about access lists. So today we're going to look at how we can implement access lists using software defined networking. So uh, while I'm doing this lab, I want to go over some of the basics of software defined networking again. So let's go over the nodes. Um, The objective of this lab is first to look at how software-defined networking can be used to build a simple layer 2 switch. Okay, and then after that we're going to use the same switch to implement um, access lists using OpenFlow protocol. So in our scenario here, software-defined networking is implemented using the OpenFlow protocol, which is the southbound protocol between the controller and the switches. What you need to do before um, the lab is to get the IP address of the virtual machine that you're supposed to use, and then use either the Windows command prompt or something like Solar Putty to start two SSH sessions to the VM, right? And we're going to use these, and we need also a browser. So we need two terminals and a browser. First, we're going to talk about the lab environment, and then we'll get into the details of the lab itself. So our lab environment consists of one switch, uh, one SDN controller, and four hosts. So the switch is implemented using Open vSwitch, which comes with many Linux distributions. It's built in, or you can download it. Um, the software-defined networking controller is RU. It's open source and also installed in the VM. And the nodes and the network environment itself is created using the Mininet emulator. So all of this is implemented within your virtual machine that you're going to use. Typically, an open flow network, uh, when you start a switch, the switch doesn't know anything. It doesn't do anything. So unlike traditional switches, you can turn them on. By default, they will pass traffic. OpenFlow switch, unless you provide it with instruction from the controller doesn't do anything. The switch doesn't do anything. And also, the controller itself is not. It's like the operating system, so it needs an application. Actually, the controller receives its instruction from an application that tells it what to do, and the controller translates the application instructions to open flow messages, and those messages will go to the switch. So it's really the user applications that determine what the network will do. So here is our environment. So we have an open flow switch with four ports, each port connected to a host. We have a controller, and um, in open flow networks, the controller connects to the switch using a dedicated interface. And so the red dashed line here is is the connection between the controller and the switch, and this happens to carry open flow messages, and the blue lines are simple data connections between the host and the switch. So in our lab, we will not focus on the operation of the switch itself, um, but we will focus on how we make that switch um, secure by adding access list to control what traffic pass through the switch from one host to another. But to just as we go through this, we need to understand a little bit about how the switch works. So, a traditional switch uh, will receive a packet from a host, and initially it will look up its MAC table. If it doesn't find the MAC table, the destination MAC table, if it doesn't find the destination MAC address in the MAC table, it will flood the packet to all ports except the one that where it came from. Eventually, the switch will learn where each MAC come from, and when packets come to the switch will forward them to the ports according to the MAC table. So it will look up the destination MAC in the table, find which port usually it comes from, it will send the packet to that port. So it starts by flooding and then learns as it goes along. OpenFlow switches don't have MAC tables. They don't. They everything in the switch depends on something called an open flow table, or flow table I should say. The flow table instructs the switch on what to do. They don't have a MAC table. The flow table is simply a forwarding table that looks at the packet, matches it, and if it finds a match with one of the table entries, then it will execute an action, and that action could be forwarded to that port or send it to the controller or drop it or whatever, right? So the action it depends on, it's programmable, it depends on what we want it to do. So before we continue, we will just look at how the OpenFlow switch works um, as a layer 2 traditional switch. So I'm gonna use, maybe to help me do that, I'm gonna use the whiteboard to explain the steps. So let's take a look. Let's assume we have this switch. Within the switch itself, we have these tables, we call them flow tables. And right now, we'll just look at simple, we're not going to go into details, we're just going to look at few fields. The most important field here is the match field and the instructions field. Okay, so the switch has ports. One of these ports is connected to the controller. And these 4 ports connect to hosts. So how does this open flow switch work? I should say, continue that. First I'm gonna talk about one scenario, then we'll go to another scenario. So um, a host send, let's say H1 sends a packet to the open flow switch. Open flow switch, I'm gonna use red color to represent packets here. So the packet comes um, and it has, let's say, 2 as the address of the host number 2, and 1, this is the MAC for host number 1, and then the payload here, right? So it matches, it comes to the table, and the table initially has only one entry that says any packet forwarded to um, the controller. I'm just gonna write output and here controller. This understood as choose the output port as the controller port. So the packet will be sent to the controller. The packet comes here. So in the controller, we have the controller in this case implements something like a MAC table. So the controller looks at its MAC table, and it has a MAC table for every switch in the network. We have only one switch right now. So it says if the MAC is initially is empty, so the MAC and port fields. The controller looks at the MAC table. It doesn't have neither host 1 nor host 2 MACs in it. So what it will do, it will say, okay, I'm gonna record MAC host 1. It's coming from port 1, so I'm gonna record it in the table. And since I don't have information about the destination, I'm going to send the packet back to the switch and ask the switch to flood the packet. So what happened is the packet will be flooded. It will go to 234. Host 2 will receive it as a result, right? So it will come to host 2. So imagine these red arrows or red flows as the direction of the packet. Host 2 at some point will reply. Again, it will put its MAC, it will put the destination MAC, this is 1. It will put its source MAC, its own MAC, and the payload, and it will send it back to the switch. The switch will match with any, it doesn't have any other entry but this one. So it matches the any entry, and the output will be, or the instruction will be output to the controller. So the packet, this new packet, will come to the controller. The controller looks up the table and say, okay, so the destination is 1, and I know port 1, MAC 1 is in port 1. Well, that's great. And I also going to record the port where this packet came from, which is port 2. Now I have this information. I am going to send, I'm flooding this network right now, or actually no, it's not flooding yet. I know both the source and the destination. So I am going to instruct the switch. So from now on, if the packet comes from port 2 with a source of H2 and destination H1, then send it to port 1. So the output will be port 1. So that will be the entry. And then it sends the packet back to the switch and say, well, now the switch know how to forward the packet. The switch will look up this entry and say, okay, now I know this packet, how to forward it. So I'm going to forward it to port 1. When the reply comes back from H1 again, the controller will do the same thing and add another entry here that says if the input port is 1 and the source is H1, destination is H2, then send the packet to port 2. Okay, so now the controller will tell the switch how to fill its table. So from now on, any packet between H1 and H2 is not going to be forwarded to the controller anymore. It's going to be passing through the switch, and the switch will match these entries. So the packet is either match this one or match this one. Right? Any packet that is not part of these two hosts will match the any, so it will be sent to the controller and the controller will fill the table accordingly. So if you continue doing this, the controller will have information about all the hosts and it will tell the switch how to forward the packets to all hosts. Now you notice they left one column here empty. This is a priority column. So the priority column will use it to assign priorities. The reason for that is if you look at any, it's not like an normal access list, and this is something that you need to be very careful about and listen to it carefully. Access list, as you know, they will match from the top and going down. As soon as they find a match, the action will be performed, and that's it. The packet will not go any further. Right? In this table, the packet may match any number of entries. In this case, the packet will match, it could match this one, but it also will match this one because any will match any packet. So in any scenario, any packet will match at least 2 entries, if not more. So how can we, if we match 2 entries, how can differentiate which one we will take the instructions from? This one or this one? So that's why we need a priority. We need a priority so that the highest priority is the one that we will use. So a packet coming from H1 to H2 will match this entry, the first one. It will also match the third entry. So we need a priority to make sure that this instruction will be used, not this one, not the controller. Okay, so that's the simple operation of the switch. So now, how can we make this? How can we implement access list using this concept? So the only thing we need to add here is another table, and I have to draw this a little bit more accurately. So we will use 2 tables. The first table, we will call it an access list table. This will be concerned more about security. So we'll use the priority field, the match, and the instructions. And the second table will be used for the forwarding, the same. We call it forwarding table or any other name. By the way, names are not important. This usually called table 0, and this is called table 1. So the numbers are important, not the names. Okay, so what do we do in this table? This is if we want to implement the concept of permit by exception, deny by default. So what we will do, we'll say here priority 0, match any, and drop. So anything will be dropped. So any packet that comes to the switch from the ports will be dropped. Doesn't matter. If it comes to table 0 first, it matches the any, it will be dropped. So we have to be, our job here is to be selective about what we will pass to the second table, which will do the same thing that I explained here. So initially we'll have any and output to the controller. I'm just gonna abbreviate things here a little bit. So let's say I want to pass ARP. Well, we need to pass ARP. So what we need to do is create, maybe make sure that the priority is a little bit higher, and then say if the protocol is equal ARP, then what is the instruction? Go to table 1. So any ARP packet will be sent to table 1. Table 1 will act the same as before. Table 1 will match any packet. Here it will send to the controller. The controller will look at the ARP. ARP initially, if it's an ARP request, then the ARP packet itself will include broadcast as destination, and then specific port, specific MAC as the source, and then the request itself in the message. So it doesn't matter. So the controller will say, I'm building the my MAC table. This came from port 1, so I'm going to put the MAC here and the port here. So this is the MAC, this is the port. And since it's a broadcast, I'm going to ask the switch to flood it. Okay? When the reply comes, the reply will come as to H1 from H2, and then the reply. It will pass through this table because it's an ARP protocol, so it will pass it to table 1. Table 1 will look at it and say, okay, any packet will go to the controller. The controller will look at it and say, okay, so I'm gonna put the information that I just learned in the table, but now both source and destinations are recorded in my MAC table. So I'm going to send the instruction to the switch to tell it from now on, you know what, you packets between these two, they don't have to be sent to the controller, just deal with them directly here. So we were gonna copy the same instructions, same entries that we wrote here, we're gonna put them back. So I'm not gonna write them down again, but you will see what I mean. So from now on, I'm not gonna talk about table 1 anymore. What we will do here is deal with this access list. So now we can put any, this will be like our access list, and we can put any match, and the action will be, if I say go to table 1 means permit. If I drop it means drop, right? So I'm going from now on to look at ways to allow certain packets to continue to table 1. Any other packets, it will be dropped. So with this being said, here we have questions about, if we look at the notes, we'll see we have questions about packet in, packet out. So the short answer is this message, this packet, when it's sent from the switch to the controller, it has to be encapsulated inside an open flow message called packet in. and it's sent to the controller. And then when the controller sends the same packet or another packet back to the switch, the controller has to encapsulate it inside a packet called packet out. So briefly, uh, the open flow message that takes a packet from the switch to the controller, we call it packet in. The open flow message that takes a packet from the controller to the switch, we call it packet out. And the flow modification packets, by the way, I was drawing it without showing, so this is what I was talking about. I didn't switch the screen. So the packet in will be encapsulating uh, the packet that the switch receives and sends to the controller, and the packet out is used to uh, encapsulate the packet that the controller sends to the switch. And then we have here the open flow or flow modification message. These are the messages that go from the controller to the switch and instruct the switch on how to fill the entries in the flow table. Okay, so these are the three main messages that we deal with in this lab. So let's take a look at now. We'll do the simple thing, which is running the switch application. So to do this, we need to run first we need to run Mininet with the one switch for host scenario, and then we need to run the controller. The controller itself runs the application. So this is a shortcut to run the controller, and then we attach application to it. So the application we'll call it Learning Switch ACL, which is a Python application that does this automatically for us. Does the learning automatically for us. Okay, so and there's another application that runs as part of this shell script here. It's called Flow Manager. So the Flow Manager is a GUI that allow us to look at all these tables that we talked about in a nice way. You probably did something like that in previous courses, but manually. So we'll do this. Using the GUI. Okay, so what I will do here is go to one of I chose to use two terminals. One is PuTTY, uses PuTTY, and the other one is using the Windows prompt or Windows command prompt. So I am going to use one of them here to run Mininet. And actually I'm going to use the command because it's easier for me to use this function here. So SSH and then the username, and yeah, the switch is different than yours, so don't worry about this. All right, and I'm going to run Mininet here. If you want to look at the topology itself, you can look at the file as another Python code. Okay, so now Mininet works. I'm gonna set this aside and go for the other one and run the controller. So the controller I run it by running this command, and sdn. By the way, before I continue, let me show you the content of this script. So here, um, this is a script. It clears the screen. It kills any manager that's running, if it's running already, because we cannot run two managers at the same time in the same VM. So I'm killing any manager before, any controller. And then you notice the last line. The last line here runs the controller itself, and then runs an application called Flow Manager, and takes a parameter. So the parameter, the added parameter, is in any other application that you want to run it alongside the manager. So the Flow Manager. So I am going to run the controller and then run the other application, which is the learning switch. So now we see from the commands that if you see this error, don't ignore it. But this, if you look at all these messages, you see some of them indicating that the controller is contacting the switch and they establish communication. All right. So from that point on, that we'll leave it running in the background. Don't touch this terminal unless you have to, and we will go back um, to the other terminal. So the other terminal, let's see. Our instruction here says ping from host 4 to host 3. So I'm going to say here ping 3 h4 ping h3. Ping doesn't work. All right, why? Let's go to our browser and visit the flow manager, the GUI. So how do we do that? We'll go to your IP, your VM IP address, port 8080, and home slash. Right. The switch ID here, this shows you the switches and some information about the switch. So the switch ID is 1. Here the manufacturer, the description, and other information about all these port description, port statistics, flow summary, etc., etc. Let's go to the flows and see. So here we go. So if I let me refresh this for a second. See, what is the initial status of the switch? So when this application runs, the application that we call Learning Switch ACL, this one, right? When the application runs, it inserts certain entries in the switch. So one of the entries is in flow table. It says here any field, send it to the controller, and gives a priority 100 here. Any packet, send it to the controller, right? Table 0, it has an entry that says any drop. So that's equivalent to deny all, right, in access lists. But if the type is 2054, send it to the table. Now guess is what this type is. This is ARP. So when I go back and ping between H4 to H3 again. So I'm gonna do it in the background here, but watch what happened. So ARP protocol goes back and forth. Ping won't work, but the ARP goes back and forth. So the controller learned about the two ports and the two MACs and entered the two entries here. One that says if the packet comes from port 4 with source MAC 4 and the destination, sorry, I'm going to show you here. I'm having a hard time switching between terminals, so I hope I don't forget. So if let me do that again since you didn't see it. I am going to wait until this expires. So the entries expire after a while. You see the duration is increasing until there is no more traffic. So now we went back to the initial case. Let's go back to the terminal here, and I'm going to ping. Okay, I'm going to ping between 4 and 3. Okay, now let's go back to the browser. Now the browser, if I refresh, I see that the controller added these two entries because ARP packets will be passed from table 0 to table 1. It will be sent to the controller. The controller will learn about the MAC tables, the MAC addresses, and it will instruct the switch that from now on any packets from this host to this host is allowed, and any packet from this host to this host is allowed. So that's great. So I don't have to worry about now the switch learning where to forward the packet. But still, my access list here allows only ARP. It doesn't allow ICMP. That's why ping, when we go back, ping doesn't work. But it allows ARP. Okay, so the next step in our um, task here is to configure this table, to allow ARP, ICMP, I mean. So how do we allow ICMP? What we will do is to enter these entries manually. So we're going to tell the switch through the controller that we want to um, enter a new field here or a new entry, and the